Okay, all right, let's start. Okay, so we have talked about friction and its effect. Okay, and then one thing that is actually very related to friction, right, will be air resistance. Okay, so an object falling with air resistance. Okay, so one thing that we can think of will be skydiving, right? So the person dropped from the helicopter, and then after that, uh, he will fall, right? He will fall, and then after that, he will open up his parachute and after that he will land safely. Right? Okay. Fully lah. Right. So the thing is this, right? Okay. In reality, right, when you are falling uh from such a tall height, right? Okay, so the thing is that you will experience air resistance, right? So it's quite similar to when you run 2.4, right? When you run 2.4, actually you also experience the wind, right? Okay. Hitting against you. Okay, so object falling with air resistance. Okay, how does it look like actually? Okay, so firstly, right, when the skydiver jumps out of the plane, right, the only force acting on him, right, is his weight. Okay, so the weight is constant, right, because the person is still on Earth, right? Okay, so when the only force acting on him, right, is his weight, okay, he will accelerate downward at 10 meter per second square. Okay, the question is why? Okay, so if we see, right, okay, F net, right, is equals to MA, okay? And then the thing is that your F net is only just the weight, right? So weight is equals to MA, right? And then remember what we say? Remember in chapter 3, right, we say that weight is actually equals to mg, right? So this means that actually your A, right, will be your acceleration due to free fall, right? The acceleration due to the Earth gravity, okay? And then after that, we continue on, okay? So as he start to fall, the velocity of the skydiver increases. Okay, right. So the thing is that when the speed of the object increases, the air resistance increases as well. Okay, so how can you visualize this? Is when we run 2.4, right? The faster we run, the harder the wind hit on us. Right? Okay, so velocity increases, the air resistance opposing his motion, right, also begins to build up. Okay. So I have one downward weight, right? I have a downward weight, but at the same time, I have an upward air resistance as well. So the net force downwards is reduced, but there is still a resultant force downwards. Okay. However, the rate, right, will be lower than 10 meter per second square. Okay. The acceleration will be lower than the acceleration due to free fall. Okay. And then after that, right? Okay. Air resistance will increase with velocity. Eventually, the air resistance is equal, okay, to the weight of the skydiver. This means that the forces are balanced, right? Upward force equals to downward force. There is zero resultant force. So when there's zero resultant force, right, you have zero acceleration. Okay, so the skydiver will fall at a steady velocity, and this is what we call the terminal velocity. This one is very important. Okay, so terminal velocity means what? Means the velocity at the end, right? So no more in, right? But that is when he haven't opened the parachute yet. Okay, right? You realize the first three stages, right? The parachute haven't opened. Okay, so the skydiver have reached a terminal velocity. So this means that the skydiver, right, will fall, okay, at this constant speed, at this constant velocity, right? So you can see here, okay, you can see here the air resistance and the weight, the length of the arrow is the same. And then afterwards, right, we have object falling with, and then afterwards, right, the skydiver will now open his parachute. Okay, so once you open the parachute, what happens? The large surface area of the parachute, right, will give rise to the high air resistance, okay, acting upwards, which is greater than the weight of the skydiver. So this time around, this means that what? Now my resultant force out, right? Now my resultant force is upwards, right? It is opposing the motion of the skydiver, right? Because the skydiver is going downwards, huh? Right? So the skydiver is going downwards, but the resultant force is upwards. So what does it mean? This means that we have a negative acceleration. Okay. right? And then when we talk about negative acceleration, this means that the acceleration is in the opposite direction, right? So this means that the skydiver is decelerating. Okay, so when the skydiver is decelerating, okay, so this means that the skydiver is also decreasing the velocity, right? Okay, skydiver is decreasing the velocity, right? So the velocity decreases, right? So this means that the skydiver will slow down. Okay, and we say and we talk about this, right? That when the speed of the object increases, the air resistance increases also. So then the vice versa will be the same as well. The speed of the object decreases, right? When the speed of the object decreases, the air resistance also decreases as well. Okay? So the skydiver continues to slow down until the air resistance acting upwards equal the weight of the skydiver. And then by this time, okay, there will be what? The acceleration then will be equals to be zero again. Okay, so the acceleration and so the negative acceleration, okay, take note, the negative acceleration decreases to zero. Okay, so then by this time, right, the skydiver will reach a new terminal velocity, and then it will drift to the ground with this speed. Right? Okay, so how does it look like? Okay, how does the velocity time graph look like, right? Is firstly we take a look at stage one first. Okay, so for stage one, what do you have? You have constant acceleration. Okay, for stage one, you have constant acceleration downwards, right? So constant acceleration, right? So this means that the velocity is increasing at a constant rate, right? Which is why you have a straight line here. Okay, you have a straight line here. Okay, and then after that, right, we go towards this part. So now we have a acceleration, right? So now what do we have? We have a deceleration. Okay, we have a deceleration. All right, so this means that my velocity, we have a not deceleration, sorry. Now we have a decreasing acceleration. Okay, we have a decreasing acceleration because of the air resistance. So decreasing acceleration, what does it mean? It mean that my velocity, does it mean that my velocity stop increasing? Does it mean that my velocity decreases? No, right? Because decreasing acceleration, right? This means that my acceleration, right? A is still positive, just smaller. Right? So this means that the velocity is still increasing, just at a slower rate, and therefore the curve looks like that. Okay, and therefore the curve looks like that. All right. Okay, and then right, we slowly move towards resultant force is equal to zero. Once resultant force is equal to zero, so this means that what F net equals to zero, A will be equal to zero, and therefore this is why your velocity remain constant here. Right? This will be your terminal velocity. Right? Terminal velocity one. Okay. Why one? Is because once I open up the parachute, okay, once I open up the parachute, F net is you think about it, right? Your resultant force, right, will in a sense uh negative lah, right? Because we take downwards as positive, right? So your resultant force at this timing, okay, is upwards, right? So it would be negative. Okay, so then this means that I have an acceleration. Okay, and I have that acceleration, right? That is actually uh I have an acceleration that is at first quite high. Initially when I open up the parachute, right? That's why maybe you all won't experience this lah, right? But then the thing is that it's as if someone suddenly pull you back. Right? It's as if someone suddenly pull you back. Okay, the acceleration initially is quite okay. Right, but then as velocity decreases, right? Okay, velocity, okay, decreases, okay, air resistance decreases. Right? As velocity decreases, air resistance also decreases. So that is why, right, this the gradient, right, the gradient is also decreasing. Okay, you see here, right, the gradient is decreasing. Right? And then afterwards, right, when the object reach a new terminal velocity, then this is what happens, like, right? You have another constant velocity, right? Here, then that is where we go back to the fact that F net is equals to zero, and then A will be equal to zero. And this is how a skydiver can land on the ground safely, right, after falling from such a big height. Okay, all right. Okay, so this one I clarify again. Okay, so the thing is that your acceleration, right, will the upward acceleration, like you think of it this way, the upward acceleration, right, that is opposing, okay, upward acceleration, okay, that's opposing the object, right, okay, decreases, okay, as air resistance decreases, right? So initially it started steep, okay, right? It's as if someone pull you back suddenly, right? It started steep, and then after that, okay, it will slowly decrease, right? Okay, so this is what we have. Okay, so this one will be decreasing acceleration, but it will be, put it this way, it will be a decreasing acceleration in the opposite direction, then that means decreasing deceleration, right? Downwards lah. Okay? Okay, so this will be all. Okay, this will be all. Right? I hope this is useful for you guys. All right.